Hey everyone, we're here to present our project, which is persistent logging system in OpenJ9 JITServer technology. So to introduce myself, my name is Xuechun, and then
I am Chase, and our mentors are Marius, and who unfortunately could not be here this weekend, and thankfully Daryl stepped in and helped us out this weekend as well.
So to introduce a bit more about the background of this project, so you guys may be wondering what is OpenJ9. So OpenJ9 is basically, if you guys heard of Hotspot, JVM developed by Oracle. So OpenJ9 is just like a Java virtual machine implementation developed by IBM. And then what is JITServer? So in OpenJ9 Java virtual machine implementation, it has decoupled the JIT compiler from the rest of the JVM. So as a independent process, either hosted on the same machine as the rest of the JVM, or hosted on a remote machine. So this independent process, we call it JITServer. So to compare the classic JVM implementation as well as the JITServer version of the JVM. So the classic one, the JIT compiler is embedded inside the JVM, and then it's kind of like one-to-one relationships. So like one compiler serves one JVM. However, in JITServer, we have a JIT compiler isolated from the rest of the JVM, and it hosted on a remote machine. It could be on cloud, and then the JIT compiler would just be like one-to-many relationships. It could serve more than at least one Java virtual machines. And to talk about the advantages and disadvantages of the JITServer this technology. One benefit is that it doesn't eat up the CPU cycle allocated to JVM, which improves the performance. The second benefit would be it kind of improves the robustness of the Java application, as well as makes the Java application more stable, because the Java application doesn't. It's okay. So if the JIT compiler crashes, it crashes because of JIT compiler, the JVM won't be brought down anymore. So it will be stable. So the robustness is improved. But one of the disadvantages is that the network latency. So the JITServer, the JIT compiler is now on the other machine. So it has to communicate with JVM through network calls. In a perfect world, we would imagine there will be only one network call. So basically, the JVM would send a request to a JIT compiler with the code that needs to be compiled, and then the JIT compiler would just send back with the compiled method body. But in real life, the JIT compiler will send multiple queries to JVM asking about the runtime environment, like methods, variables, and profiling information. So they're more than just one network calls. Yeah. So let's talk about our project.
Yeah. So our project is adding a specific new feature to JITServer. So the current problem with the current implementation is that enabling a persistent logging in the just-in-time compiler increases the CPU and memory needs of the whole program significantly. So therefore, it is expensive to enable logging, except when you're working with a just-in-time compiler, since it's not statically compiled, the decisions made by the compiler could be important for debugging purposes, because you don't always get the exact same output for the exact same input. Depending on how the environment changes around that method, it might compile slightly differently. So these kind of decisions on optimization are often important for debugging information. However, if you turn on the logging, it slows everything down. Yeah, so one of the possible, sorry, could you go back one slide? Yeah. So the possible solution in theory is now that we have the JITServer decoupled, or sorry, the JIT compiler decoupled into JITServer, we now have more resources on the host machine that the JITServer is running on, and we can therefore take the hit in CPU and memory resources and enable logging in the cloud. So the goal of our project is to create a new option in OpenJ9 to enable persistent logging of the compiler decisions and store those logs in an off-the-shelf database. The reason we chose to do this is because these databases are already well documented and well established and have lots of optimization and things around that. They work well, they work fast, there's no reason to reinvent the wheel. However, we don't want to introduce a dependency on one particular database structure into OpenJ9. So to do that, we will have to, we will have to create our own implementations of the communication to the database. One reason we chose to do this is because our communication is not that, fast. But we only have a few simple operations that we want to do in the end, which is write the logs to the database and query the logs in the database. So we figured it would be more beneficial for the project as a whole if we implemented a simple interface for ourselves rather than bringing in a whole dependency of an entire driver for the database, which has all these vast features that we don't need, and that would implement a dependency which people would have to install every time they want to get OpenJ9 running, and that's not our desire. So, yeah. So this is just like a simple diagram of sort of how our project is structured. So currently, as explained before, the JVM will communicate with the JITServer, which has a JIT compiler in it already. The part that we will be hoping to add is a logging interface that will allow us to log to the various off-the-shelf databases in a simple way. So as explained, that's sort of what the drivers are, our simple interface. We'll have to sort of modify each one has its own language in a way of querying it. So theoretically, we would create an abstract base system and keep as much of the common functionality as we can in the logging interface, and only basically the query language, hopefully, will have to change in between each database. And to start, we're going to try and support Apache Cassandra and MongoDB, as Apache Cassandra scales really well to high volumes of writes, and MongoDB has a nice document storage structure that matches sort of our needs for the logs. And then we'll also have to have a retrieval system so that the users who are requesting the logs can actually get their logs back and see them. And yeah, so while we didn't actually complete too much implementation this weekend, we learned a lot about how OpenJ9 works and how it works in terms of OpenJDK. So OpenJDK is like the full development environment, whereas OpenJ9 is specifically just the Java virtual machine. And we did a lot of research about how we might want to implement this solution to our problem, and we sort of planned a roadmap of how we might accomplish that, and sort of set up our development environment, like we also set up Git and stuff like that, and create some issues, and sort of create a plan about where we want to go from here and start implementing this thing. But yeah.